All right, so this welcome back, and this is the second part of week one lecture. We are still on Kirchhoff's voltage law and Kirchhoff's current law, and this is an example, typical example of question or problem you face in under KVL. So in this example, we have to use KVL and KCL to find the unknown voltage and current. So what are the unknown voltages? Should actually be voltages because there are two here. The unknown voltages are V2 and V1. The other ones are known. All these voltage are known. The voltage across here, here, and here. They are all known. How about the unknown current? We have to find I3, I4, I5, I6, I7, and I8. So those are the unknown currents. So we have to use KVL and KCL to find that. So we'll start from the easy one first. Let's look at the unknown voltage first, because the unknown voltage are just few in number. You have just two of them. So how do we do this? Solution to this solution, the unknown known voltages are, that's V1 and V2. So these are the unknown voltages. So if you have the unknown voltage, let's see how we can find that. So how do we find the unknown voltage? We found the unknown voltage from taking KVL, because if you are looking for an unknown voltage, you have to do it. Everything you have to find is of your circuit elements or your circuit law that you apply, usually KVL. So by KVL, by Kirchhoff's voltage law, by KVL on loop 1, let's call this loop 1 and let's call this loop 2. So we apply KVL to loop 1, but then to make the work easy, let me apply it first to loop 2, because if you apply it to loop 1, you have two unknowns. But let me apply it to loop 2 first, and then you see why we did that. So if you apply KVL, remember our journey is in the anti-clockwise direction, and then whatever polarity or sign that the voltage carries at the point where we entry is the sign of that voltage. We are not interested in the exit. This is the entry point, this is the exit point. So we are only interested at the voltage at the entry point, the sign at the entry point, and then our journey is in the clockwise direction. So by KVL on loop 1, I'll start here, go this way, that way, and then right back to where I started from. So from here we get the polarity of this voltage is going to be what? Plus V1, because the voltage across this element is plus V1. There is no any other element apart from this. This is not an element, of course. This is not a circuit element, it's just a current symbol. So from here you have V1, then here is going to be plus 5 volt as well, because the sign at this point is 5 volt. So down to this place you'd have plus 3 volts. Let me leave the volt out, plus 3, and then we are down to this very place, and then you have plus 2, and then you're back to where we started from. That is when we equate our equation to 0. So remember, we are looking for V1. V1 will be equal to minus 2, that's this cross that way, then minus 3 minus 5. So if you simplify this will give you minus 10 volts. So this is the voltage across this resistor here, and then we've gotten that voltage V1 to be 10 volts. So by KVL on loop 1, we have that the sum of voltage across the terminals or across all the components, circuit elements in loop 1, when you transverse the circuit in the anticlockwise direction, it's positive, it's equal to 0. So the sum of voltage around the closed loop is equal to 0. That's the statement of Kirchhoff's voltage law. So from there we'll apply our KVL. Remember, the entry point sign is this polarity we'll be taking. So if you transverse like this, the entry point for this is going to be minus V2. Then the entry point of this is going to be minus 9 volts. The entry point for this is going to be minus V1. The entry point for this is going to be plus 11. That will be equal to 0 by KVL. So from here you have minus V2. Cross these other ones to the other side, you have them to be equal to, when 9 crosses, it becomes plus 9 plus V1 minus 11. So that's minus V2 is equal to 9. Then, V1 from our calculation here is minus 11. So plus minus 11 will give us minus, sorry, v1 is minus 10. Sorry, the value of our v1 is minus 10. So plus minus 10, that is plus v1 is going to give us minus 10, then minus 11. So this is going to be minus v2 would be equal to 9 minus 10, that will be minus 1. Minus 1 minus 11, that's going to give us minus 12. So if that is the case, minus cancel minus and you'll be left with v2 is equal to 12 volts. So this is the final answer for that, for the voltage, for the case of solving for the voltage. How about solving for the current? The current is simply by application of KCL, unknown currents are, you have I3, I4, I5, I6, I7, and I8. So these are the unknown currents. So how do we find? You take them one at a time, and then it's actually advisable you start from a node, because this is a node. Remember, a node is where two or more components come together. So this is a node, this is also a node, this is a node, this is a node, this is a node, this is a node. So we start from where I will have lesser number of unknown currents. If you start from a node like this, you'd end up with we end up in trouble, because here you have unknown current I6, unknown current I7, unknown current I4. All of them are unknown at this point. It's not as if you can't solve them, but then you're going to end up with a lot of simultaneous equations, and we want to limit that, because these are like 1, 2, 3, 4, 5, 6 unknown. So you have to systematically solve this to avoid solving systems of equations or simultaneous equations. So you have to look at nodes where you have lesser unknown. This node, you have one of these known, 6 ampere is known, minus 3 ampere is known. It's just I3 that is not known. So I'll choose that node and I'll label that. Let's call this node 1, node 2, node 3, node 4, node 5, and node 6. So let me correctly write these 3 so that we'll all see it very well. So I'll start from node 1. For node 1, remember, it is just by my labeling that I gave them the node values node 1. It doesn't mean you only have to start, you have to start from node 1 always. It is from the consideration that my node 1 carries lesser unknown. That's why I'm starting from